Exponential expressions, that is, equations with bases and their exponents, are seen throughout math and science. Despite the many ways they are used, there are only 8 basic exponent rules that you need to know. The first 5 that I will go over with you can be considered in terms of expanded, in which you'll see multiple bases with multiple exponents spread out, or condensed, in which you'll see a single base with a single exponent in a more simplified form. Let's go through these one by one to make sure that you understand the rules, and then we'll later go through examples. In the first rule, we have a base raised to the power of x times that same base raised to the power of y. Because you have 2 terms that have the same base being multiplied together, we can condense that into a single base and add the exponents. Similarly, if you have a base to the power of x divided by a base to the power of y, 2 expressions with the same base with 2 different exponents being divided, you can condense it into a single base and subtract the exponents top minus bottom. However, if you have 2 different bases raised to the same exponent, like here we have a to the x times b to the x, you can put the 2 bases together into a single expression and raise it all together to the same exponent of x. And similar to the last one, if you have a to the x divided by b to the x, that's 2 different bases with the same exponent, you can put them together as the same expression, all raised to the power of x. So it's a divided by b over x. And lastly, for these expanded condensed, if I have b to a power raised to another power, that is power of a power, we can treat it like multiplication and distribute and multiply the exponents. So it's a single base to the power of x times y. In addition to these 5 equivalent expressions that are expanded or condensed, we also have 3 extra exponent rules. Anything to the 0 power is 1. It doesn't matter how simple or small or big or complex the expression is. If it's raised to the 0 power, it is equal to 1. We also have this rule. If you have a base to a negative exponent, what you essentially do is you flip it upside down and you make the exponent positive. By upside down, I mean this is really over 1, and so I would take that base and bring it down into the denominator and make that exponent positive instead of negative. And then the last one, which is a little weird, if you have a base with a fractional exponent, treat it as if it was you were dividing fractions. So the number on top would go inside and the number on bottom would go outside. Similar concept here. So if it's b to the x over y, the x goes inside with the b and the y is on the outside. This is read as the y root of b to the x power. You could also write this in a different way, the same expression, the y root of b to the x power. Let's see these 8 rules in action by going through a few examples. When I do each of these, you're going to notice that I compartmentalize them. I do them step by step. I'll take care of the numbers first, then I'll do the x's, then I'll do the y's, then I'll do the z's. So kind of just do one thing at a time. For instance, on this first one, we'll take care of the 2 times the 7 first, which is going to give us our 14. That's pretty easy. And then we'll take care of the x's. Really what I have here is x to the 3rd times x to the 4th. And we have a rule that says when they are the same base and they have 2 different exponents, we add the exponents and put them as a single base. So what I'm going to do here is make it a single base of x and add the 3 plus 4 to get the exponent of 7. And that's your answer. Not bad, but I will warn you, they will get worse. On the next one, we will do the same thing, take care of the numbers first, and then deal with the variables one by one. So we'll take care of 8 over 12 first, which simplifies to 2/3. And then we'll go ahead and take care of the variables. So you have x to the 5th divided by x to the 2nd. We have a rule that says when you have 2 terms with the same base, with 2 different exponents being divided, you subtract the exponents and put them as a single base. So here I'm going to take that x to the 5th and the x squared, and I'm going to subtract the 5 minus 2, which would leave me with x to the 3rd. Don't forget that 2/3. This is one way that you can write this. or you can always write it as 2x to the third over 3. Both of these are fine. For this next one, it looks really complicated, and you might start thinking, oh, it's a power to a power rule, like here, where I'm going to go ahead and multiply the exponents. Oh, I have to multiply each of these by the exponent. But then you realize, wait a minute, I have a rule that says anything to the 0 power is equal to 1. So before we go and start distributing that power to the power rule, which wouldn't be wrong, it would just take us longer, we can think that anything in here raised to the 0 power is going to be 1. And that negative in the front comes along for the ride. And that's your answer. On these next ones, I'm going to go a little bit quicker and show you how you don't have to write the middle step out if you do it by grouping. So if I have x to the second times x to the third, when you have two expressions with the same base being multiplied, you add the exponents. 2 plus 3 is 5. If I have y times y to the fourth, remember that y technically has an exponent of 1 on it. So y to the 1 times y to the fourth, I would write y with 1 plus 4 in the exponent, which would give me a power of 5. I'll do the same on the next one. 6 divided by 2, we know that one's 3. Let's take care of the x's. X to the seventh over x to the third. When I'm dividing and they have the same base, I subtract, so 7 minus 3 is 4. And let's talk about this one for a second. So y, the square root of y, is actually y to the 1/2. And on top we have y, which is y to the 1. So really what we're dealing with here is y to the 1 minus 1/2, which is 1/2. And this is your final answer. You could leave it like this. Some teachers ask that you don't leave fractional exponents, so you would bring this and write it as the square root of y. For this next one, I see another to the power of 0. Thanks. Anything to the power of 0 is 1. I can either write 1 or just basically cross it off. But then I have this power to a power with a fraction and a negative just when I thought things were getting easier. But then we remember a power to a power means multiply. So I have x to the 3 times negative 1/9, which is the same as x to the negative 1/3. When we have a negative exponent, we write it down on the bottom and make it positive. This is okay. Or you can write it as the third root of x, which is also okay. Oh no. There we go. All right, let's take a look at the last 3 examples. Even though there's no parentheses around the first set, I understand that everything is being multiplied, so I'll do things one at a time. 5 times 2, 10. X squared times x to the fourth. We add the exponents. y1 times y to the negative 3. We add the exponents. 1 plus a negative 3 is a negative 2. Oftentimes, we don't like to leave expressions with negative exponents, so we would rewrite this like this. For this next one, same process. Take care of the numbers first. So this is going to simplify to 1 over 4. And you know what? I was going to show you a shortcut, but let's take care of this first. So 1 over 4. Now, I have y to the second divided by y to the negative 4. That's the same thing as saying x to the second minus a negative 4, which really comes out to be x to the positive 6. And then here, now there's my y. I have y to the negative 3 over y to the third, which is the same thing as saying y to the negative 3 minus 3, which leaves me with y to the negative 6. Don't forget that 1/4 that was in the front. Now we're going to take the negative y, the negative exponent, and bring it down in the bottom. Don't forget that 4 was down there already because of the 1/4. and then we have x to the 6th on top. We don't need the 1 anymore because we have x to the 6th there. And for this final example, my first inclination would be to go ahead and do power to the power to raise that -4, but I really don't feel like raising it to everything on top and everything on the bottom. So what I think I'm going to do first is simplify what's inside, and then I'll deal with that outer exponent. So here I have -7/3, let's leave that alone. Then I have x to the -2 divided by x to the -3. That's like saying x to the -2 minus 3. That's going to be x to the -5. I'll bring this along just to have it down there. When we're taking care of the y's, I have y to the 3 over y to the 4th. That's like saying y to the 3 minus 4, which is y to the -1. Here I have z to the 0 over z to the -3, and we know z to the 0 is 1, so we can ignore that, and really that means we're just left with 1 over z to the 3, which, if it's easier to think of it this way, you could write it as 0 minus a -3. That leaves you with the positive 3, because if I have z to the -3 in the denominator, remember we flip it to the other side, so it's essentially going to come up to the numerator and become positive. All of this is closed, and we have it to the power of -4. Now I'm going to go ahead and distribute that -4. The -4 goes to the 7 and the 3, also to the 5, the -1, and the 3. So here I'm going to end up with, and this is where you have to be careful, that negative is technically not in parentheses, so it just stays there. So it's 7 to the -4. Then we have x to the -5 times -4, power to a power you multiply. Y to -1 to the -4, power to a power you multiply. Z to the 3 to the -4, power to a power you multiply. And don't forget that 3 to the -4. Let's take care of all these negative exponents by bringing them to the other side. So I'm going to go ahead and just draw one big old line here. That x to the 20, and I'll scoot it over a little bit, that x to the 20 is not causing any problems. Leave him where he is. And same with the y to the 4th. But the 7 to the -4 needs to move to the denominator to become positive. And the 3 to the -4, which is in the denominator, needs to move to the numerator to become positive. And that z to the -12 has to move to the denominator to become positive. And so this can be your final answer. Teachers are generally okay with you leaving numbers with their exponents, but if they want it as an actual number, you can use your calculator to do 3 to the 4th and 7 to the 4th and write their number values. Obviously, these got a little more complicated at the end, but if you notice, we never strayed from our same 8 rules. I'll have the link to this PDF with the answers attached in the notes below. I also want to reference you to our logarithmic expression video, because you're going to notice that a lot of the log rules are very similar to these exponent rules, especially in terms of the expanded and condensed. And so there's a very strong connection between the two, and it'll make more sense if you study them together.